Welcome to the session on data collection, the large data set. The objectives for this session are to understand the large data set, in particular, how data can be collected from it, identify types of data, and calculate simple statistics. Your exam may include a question based on real data. These questions could include questions based on weather data. In this case, weather data samples may be provided from the Met Office for 3 overseas weather stations and 5 UK weather stations, as shown on the maps over May to October 1987 and May to October 2015. So here's the Northern Hemisphere and the Southern Hemisphere. The 3 overseas weather stations are as shown, and the 5 UK weather stations are as shown. For the large data set, the variables at each weather station are as follows. The daily mean temperature, which is the average of 24-hourly temperature readings. The total daily rainfall, including snow and hail melted before measurements. The amounts less than 0.05 are indicated by TR or trace. The daily total sunshine, this is recorded to the nearest tenth of an hour. Daily mean wind direction and speed, this is averaged midnight to midnight in knots. Wind directions given are bearings and compass directions, and wind speed is given on the Beaufort scale. The Beaufort scale, as you can see from the table on your screen, has a scale 0 to indicate calm, this is less than 1 knot, 1 to 3 to indicate light, that's 1 to 10 knots, 4 to indicate moderate, that's 11 to 16 knots, and 5 to indicate fresh, that's 17 to 21 knots. Other variables at each weather station are daily maximum gust, this is the highest instant wind speed recorded in knots. Where the gust is coming from is also recorded. The daily maximum relative humidity, this is the percentage of air saturation with water vapour. Above 95% gives mist and fog. Daily mean cloud cover, that's 1/8 of the sky covered by cloud in octas. And daily mean visibility. This is the greatest horizontal distance at which an object can be seen in daylight, decameters. And also daily mean pressure. This is measured in hectopascals. The variables at overseas weather stations are daily mean pressure, daily mean temperature, daily total rainfall, and daily mean wind speed. We are now going to take a look at the required skills you need in order to analyse the large data set. So you should be able to take a sample from a large data set, identify types of data, and calculate statistics from the data. Notice in this particular data set, NA denotes data which is not available, and this is the case for other data sets as well. Let's now remind ourselves of some terms from the previous session. So suppose we have some data. This can be divided into 2 main categories: quantitative, which is mainly numeric, or qualitative, which is non-numeric. Quantitative data can again be divided into 2 categories. Discrete data, which is data which can be expressed precisely, such as number of hats in a box, etc. And continuous data, which is data which can take on any value in a given range. And examples of this are weight and time, etc. Qualitative data can also be divided into two categories. We have ordinal data. This is data which has a natural ordering. So, for example, exam grades. And nominal data. This is data which has no implicit ordering. So, for example, favourite colour or colour of car, and so on. Now consider this fictional weather station data. We're going to take a look at an example related to it. Pause the video and have a go. Press play when you're ready to view the solutions. Now let's have a go at example 1 part A. We are asked to consider the data set shown. What type of data is daily total sunshine? So here's daily total sunshine highlighted on your screen, and it's given in hours. Therefore, it's clearly numerical data which can take any value in a given range. So therefore, our data is continuous and quantitative. And now let's solve part B. A student wishes to select a sample of size 7 from the dataset Daily Total Sunshine. Starting from day 2, she selects every third value. What type of sampling method is this? So let's solve this. Here's the Daily Total Sunshine highlighted. We start at day 2 and then select every third value. Here the 7 values which we have selected have been highlighted. Clearly, this is systematic sampling. And finally for part C, which data values does she obtain? The data values are 0, 0.6, 1.9, 12.5, 14.9, 5.8 and 8.7. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2 part A first. We are required to consider the data set shown and find the mean daily total sunshine for days 3 to 8 inclusive. These have been highlighted in the spreadsheet. So the mean is simply going to be the sum of these values, as shown, divided by 6, because we're considering 6 days. And this equals 5.25. And now for part B. We are required to find the median daily total sunshine for days 10 to 16 inclusive. So highlighting the days in question, we can find the position of the median. We're considering 7 days, as shown here. So the position of the median is 7 plus 1 divided by 2, which is equal to 4. So we need to consider the 4th day out of these 7. And on the 4th day, the median equals 5, as this is the value on the 4th day. Now let's have a go at 2 part C. The median daily total for the same week in Town A is 6. A weatherman claims that Town A therefore experiences more sunshine in this season. Explain whether your answer to part B supports this statement. So let's consider this. Now the sample is extremely small. It's only 7 days from one location, so it doesn't really provide enough evidence to support the claim. This brings us to the end of this session. If you have understood its contents, you should be able to understand the large data set, namely how data can be collected from it, identify types of data, and calculate simple statistics. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.